good morning. So yesterday we created our book of parent functions. So today what we're going to do is we're going to explore what would happen and what we would need to do in order to transform these functions. So what I want you to do is for the do now, I want you to put these two equations into the calculator, draw your table, and graph both of them on the same graph in a different color if possible. So take a minute, pause this video, graph those, and then even try to look at this question to compare and contrast the two. Okay, so we graphed both of those functions using the table. So then we need to compare and contrast what was the same about these functions and what was different about them. Well, what was the same about them? So if we look here, they're both the absolute value, so they're the same shape. And they're also the same size, right? But what was different about them? One is flips, right? So one of them is flipped over which axis? The x-axis, because it's flipped over that way. So also, just looking at the two equations, what do you notice that's different? This is the absolute value of x, whereas this is the negative absolute value of x. So that negative is actually going to be what causes the function to flip. So remember, just like parabolas, when we have a positive x squared, it's a smiley face facing up, whereas if we have a negative x squared, it's facing downwards, because that's what that negative does. So our first transformation, our rule is if we have a negative, so if the function is negated, it's going to reflect or flip over the x-axis, just as it did above. So it is going to reflect over the x-axis. Reflect or flip. That's our first rule, and you guys figured that out by discovering it with our graph. So the next question, we're going to do the same thing that we did in the previous. We're going to graph all three of those graphs in different colors if possible. And we're going to try to figure out what the rule might be with these ones. So our parent function is x squared, so that's our base. So both of these, something's going to happen. So I want you to brainstorm a little and think about what do you think might happen to the graph when it's x squared plus 5 and when it changes to x squared minus 5. And then I want you to use your graphing calculator. We always draw our table when we're graphing, so we're going to draw our table, and then we're going to put them on the graph. Try to do each in a different color if possible. All right, so when we graphed each of these equations, what did you notice? Well, let's look here. Y equals x squared is our black equation in the middle. Y equals x squared plus 5 is our red equation on the top. And y equals x squared minus 5 is our burgundy equation on the bottom. So when we compare y equals x squared to y equals x squared plus 5, what did you notice? So it's this black one compared to the red one there. What did you notice? What happened? So the equation shifted upwards. How many times did it shift up? Well, if my y-intercept is at 0 here, it's at 1, 2, 3, 4, 5 here. So it shifted up 5 units. And what was different about these equations? This equation has the plus 5. So then we needed to compare y equals x squared, which is my black equation, to y equals x squared minus 5, which was my burgundy equation. What happened here? The equation shifted which way? Down. And let's count how many units did it shift down. It started here and it went 1, 2, 3, 4, 5 units. So that's going to be the rule. And if you notice here, it shifted down 5 units because there was a minus 5. So our rule here is going to be if we add outside of the equation, there's going to be a shift up. And then if we subtract outside the equation, there's going to be a shift down. And outside and inside of the equation is going to become more apparent when we move on further in the lesson. So then looking at the next one, what I want you to do is graph all three of these in different colors if possible. Okay, so I graphed all three of those equations. So then we needed to compare them. So first we need to compare x cubed, which is that black equation in the middle, to x plus 4 cubed, which is the green equation. So how do these compare? How is the x cubed different from the x plus 4 cubed? Well, what happened there is it shifted to the left. And if we count, it goes 1, 2, 3, 4 to the left. So it shifted to the left form. What do you notice about the equation? There's a plus 4 there. Then we need to compare the parent function of x cubed to the transformation that takes place y equals x minus 4 cubed in the lime green. So how does the x cubed compare to the x minus 4 cubed? Well, this one is shifted to the right. And it shifted to the right 1, 2, 3, 4 units. And if we look at the equation, it has the minus 4 in the equation. So that's going to help us come up with our rule. So our rule is going to be if we add inside the equation, and notice this is inside before it's cubed, we are going to shift to the left. And then if we subtract inside the equation, we are going to shift to the right. So then let's look at the next example. We have y equals x squared, y equals 3x squared, and y equals 1/3 x squared. So graph each of these in a different color, and then let's see what do we notice is happening. So now if we look at these graphs that we graphed y equals x squared in the black, y equals 3x squared I did in the blue, and y equals 1/3 x squared in the negative blue. So first we want to compare the y equals x squared to y equals 3x squared there, and what do you notice? The function got much thinner from y equals x squared to y equals 3x squared. So it got thinner. And what makes the function different here? It got thinner. It almost looks like it got stretched out, right? And what's different in the actual equation is it has a 3 there that's being multiplied. Then let's look at the next one. We have y equals x squared and y equals 1/3 x squared. What happened here? The function got wider. And it's almost as if somebody sat on it, smushed it, right? And it got compressed. So what's different in that equation? Well, here we have the 1/3. So our rule here. So we're going to have y equals k x squared. So k is that number that you're multiplying it by. So if you're multiplying by, or if k is greater than 1, then that tells you you're going to have a vertical stretch. Where if the k is less than 1, you're going to have a vertical compression of that number. All right, so each of these equations, what we want to do is first identify the parent function. Then all of the transformations that are taking place, we need to identify. So this is where your parent functions book will be handy. So the first thing I'm going to do is on the side, I'm going to write what the parent function is. And here we see we have a square root of x. So my parent function is y equals the square root of x. So now anything that's different than the square root of x is going to be something that we need to identify as a transformation. So if I look here, first I notice I have a negative, and looking back at the rule, what does the negative tell me is happening? The negative is telling me we are going to reflect over the x-axis. Then we're multiplying by a 3. We're multiplying by a 3. So that is what we just did. So that tells us we have a vertical stretch. Of 3. Okay, then we have x minus 1. And this is inside of the radical, so it's inside the function. So when I'm subtracting inside the function, what does this tell me is happening? Well, this tells me I am going to be shifting to the right 1 unit. And then here on the outside of the function, I have a +4, so that tells me the function's going to go up 4 units. So let's look at example 2, and let's try to do that one together. So first we need to identify what is the parent function here. And my parent function, I see it's cubed, is y equals x cubed. So then anything that's not x cubed, we need to figure out what that transformation is. So the first thing that we see here is it's being multiplied by 1/2. 1/2 is less than 1, so what does that tell you is happening to the function? This tells you that there's going to be a vertical compression. Okay, then we have x plus 1 inside the function. So that tells you that our function is going to be shifting to the left 1 unit. And then finally, we are subtracting 6 on the outside. Subtracting 6 on the outside will tell me that we are going to shift down 6 units. So I want you to take a second, try 3 and 4, and then I'll put those answers up. Alright, so here are the answers to examples 3 and 4. If you have any questions, please comment on the video below so that I can answer them. Also, if you look at the bottom of the sheet, now what you're going to do is you're going to complete the quadratic function transformations cut and paste sheet. But your answers are going to go on a Google form link that's on the e-board. So this is the worksheet that you are going to complete. Each of these goes into a box, so you could simply cross it out and write it in, then put your answers on the Google form. If you have any questions, please feel free to comment on the link. I hope you are staying safe and healthy.